Hello, this is the third part of 3 recordings on finding definite integrals by substitution. So we're gonna apply fundamental theorem of calculus part 2. And in these lessons, we want to show you how to show work, okay? How to show work, and which I believe is a question of many students. So let's continue. We have 5 more. I think we have 1, 2, 3, 4. We have 5 more questions to work with. Okay. On this question, we're going to, do substitution. Feel free to pause and do your own. Come back to compare with answers, or you can just do your own without coming back to check your answers. And du equals to 1 over x dx. Okay, you can see we actually have x divided into dx. Oh, wait, sorry, this should be 1. Okay, we should not have 2 dx. But anyway, so this is x under dx, so that's a du. So we have a du already. And then the substitution is going to be from x to u. Okay, and x changes from e to the power of 4, and u will be changed accordingly. When x equals to e, ln e equals to 1. When x equals to e to the power of 4, and that equals to 4. So the interval change, we have 3 parts, right? We're going to do 3. 1, 2, 3. Interval change from 1 to 4. Oh, sorry. 1 to 4. Function. Okay, we got 1 over root u. Root u, because u equals ln x. X joining the dx, right? We got dx over x, and that's du. So that's our du. Okay, so in our expression, our substitution must be complete. Otherwise, if you have an x here, it's not going to make it true, right? So it's going to generate a false statement. So you make sure it's either completely x or completely u. By this time, the next step should be pretty straightforward. Okay, it should be pretty straightforward. And the u here, so you may like to write u as raised to the power of a -half. We have done this many times over. The antiderivative of u raised to the power -half is 2 times u raised to the power of half. Evaluated at 1 and 4. Okay, 1 to 4. And then apply fundamental theorem of calculus part 2. So we have u raised to the power of half substituted by 4, subtracting u raised to the power of half substituted by 1. All right, and equals to, so we got a 2 outside, and this is 1, and this is 2. 2 minus 1 is 1, so the final answer is 2. Okay, so that's one way to show work. Another way to show work, is that we're going to, instead, we're first going to find the antiderivative, okay? Because we have this fundamental theorem of calculus part 2, okay? So we know that fundamental theorem of calculus part 2, we know that in that theorem, we need any antiderivative. We basically just need a 1, We just need one antiderivative. So instead of doing the definite integral, we just do the indefinite integral. And the substitution is going to be the same. The substitution is the same. Okay, we have the same substitution. So we just want to find the antiderivative. So from this process, right, we're going to get a root u. So here is going to be du, right? Dx over x is du. So this is going to be root u. And of course, that's u raised to the power of -½ Okay. And our answer will be 2 times root u. You can write power if you want to, plus a constant. Okay. Last but not least, we're going to have to substitute u back. And u was ln x. U was ln x. Okay. So after this is done, we're going to apply fundamental theorem of calculus. We're going to choose an antiderivative, capital F. Okay, so we're going to choose, you can say let's capital F of x equals to, if we just need to choose one, right? So I'm going to choose one by, letting c equal 0, right? Then we're going to choose, we're going to do f of capital A, f of capital B minus f of capital A, right? And you can also write this way, okay? Because we already have found the antiderivative, so you can write it this in the following way. You're going to write it as a capital F of e to the power of 4 minus capital F of e, which is going to be 2 times, okay, e to the power 4. Okay, 2 times e to the power 4, replacing x, subtracting, I'm sorry, capital F, right, and e. Then you just evaluate. And finish. Okay, so that equals to 2 times root 4, because ln e to the power 4 equals to 4, minus 2 times ln e equals to 1. So in the end, we got a 2 times 2, which is a 4. 4 minus 2 is, okay, so that's another way to do it. So the other way to do it, you basically separate it into 2 parts. The first part is to find the antiderivative. If you need to do substitution, you do substitution. The second part, you take one of the antiderivative, one of it is sufficient, and then you just plug in, following the fundamental theorem of calculus part 2. Okay, so let's do the number 76. Number 76. 5 more questions. Okay. U equals to, apparently I'm going to choose u equals to x minus 1 squared. So du would be equal to 2 times x minus 1 dx. Okay, we're applying same rule here. Okay. And luckily, we have x minus 1 multiplied dx, right? We have x minus 1 multiplied dx, so that's du, right? So bear in mind, so we can bring these two together. And that's our half of du. This is half of du, right? So we're getting closer to it, and let's work out the table. Let's work out the table. So x u, okay, u equals to x minus 1 squared. X changes from 0 to 2. and u equals to as x equals 0, right? -1 squared is a +1. As x equals to 2, and that's equals to a +1. Okay? All right. Let's see, what are we getting here? Okay, this is interesting. This is an interesting question, isn't it? So I'm going to just quickly double check if I copy the question correctly. Okay, number 76, from 0 to 2, from 0 to 2, x minus 1 multiply e raised to the power x minus 1 squared. Okay, I copied the question correctly. So what we are getting? What we're getting is that we're getting an integration, right? When x, basically the lower limit and upper limit now is changed to be the same number. 1, upper limit 1. Is that right? Let's double check. X equals 0. 0 minus 1 is -1. -1 squared is +1. Well, x equals 2. 2 minus 1 to the power 0, to the power 2, that's going to be 1 again. So this integral, no matter what this is turn out, okay, even though we're going to have e raised to the power of u half du, and this is going to be half, it's going to be 0. It's going to be 0. Why is it going to be 0? Because we have a property. We have a property here. Okay, so let me bring it to you. We have this property. When the upper limit and lower limit are the same number, okay, when the upper limit and the lower limit are the same number, no matter what the function, the derivative is going to be 0. Okay? All right. Next one. Okay, next one. It's going to be u equals to the entirety of the denominator is u. Okay, and u equals to e to the power of z plus 1 and dz, dz. All right. And so that's happen to be the interval, happen to be the numerator, right? Speak about academic questions, right? So this is z, this is u. Okay, z changes from 0 to 1. Sorry, 0 to 1. And u, when z equals 0, and this equals to, oh, sorry, this is 0. Okay, equals to 1. When z equals to 1, and this is a 1, and this equals to e plus 1. Okay, so the interval, the integration, the definite integral will be changed to another interval with respect to u, and the limit is 1 to 1 plus e, or e plus 1, same thing, okay? And we will have 1 over u du. Okay, 1 over u du, right? Because the numerator times the dz is du. And the next is ln u, evaluated at lower limit 1, upper limit e. So that's going, oh, no, sorry. Lower limit 1, upper limit e plus 1, or 1 plus e, same thing. And so that equals to ln okay? E plus 1 minus ln1. ln1 is equal to 0, so the final answer is ln E plus 1. Finish. Okay, so that question is done. So these couple questions, and you will get to use some of these interesting properties. I'm going to use some of these interesting properties. So 3 more to go. Okay, so let's see. What are we going to introduce in this case, right? We get x, square root of x. We have x plus 1, right? So let's try u equals to, how about we try u equals to root x, okay? And u is equal to 1 over 2 times root x dx. You can see we have dx over root x, right? dx over root x. So dx over root x over root x, and that is going to be twice of du. But what are we going to do with x plus 1? What are we going to do with x plus 1? Okay, and this is what we can do. Okay, x is between 1 and 4, so x is always positive, so we can square both sides. We will get a u squared equals to x. U squared equals to x. So what will be 1 x plus 1, right? X plus 1 in turn is going to be u squared. Whoops, u squared plus 1. That's looking up, right? All right. This is a bunch of algebraic expressions, but just remember, we are dealing with a bunch of academic questions, okay? So they didn't mean to make our life impossible. So there is a way. So x changes from 1 to 4, and u, right? When x equals to 1, u equals to 1. When x equals to 4, u equals to 2. So this given definite integral, the interval would change from 1 to 4 to 1 to 2. Sorry. This is up. Wait. 1 to 2. There we go. Now let's see what's under, right? dx over over root x is 2 times du. So we get a 2 times du, right? So that part was taken care of. And how about the other part, right? How about the other part? Well, x plus 1 is u squared plus 1. So u squared plus 1 under 1. Okay, if we bring the 2 outside, we're almost there. Okay, so we get 2 times arctan of u evaluated at 1, 2. Okay, lower limit 1, upper limit 2. Okay, so near the end, 2 times arctan of 2 subtracting arctan of 1. Okay, and what would that be? You do not need to use the calculator. Okay, so I'm just going to show you the answer. The answer is arctan of 2 minus pi over 4, because we know that arctan of 1 equals to pi over 4. That's it. So you don't need to go further. You do not need to go further. Okay? That's it. Two more. Okay, these two questions are a bit more challenging. It's a bit more challenging. Actually, before I record, I had to figure out how to do it. Okay, before I get on this recording. Okay, so now let's look at in this first case. The first case, it seems that we should introduce 1 plus root x as our u. Okay, that seemed to be the most obvious choice. Okay, and then what? And then what? Okay, or, you know, let's just try it if it works, right? So du equals to 1 over 2 times root x dx. Let's see if this will work, right? Interval change x u x is from 0 to 1, and u would be when x is 0, and this is equals to 1, when x equals to 2, I'm sorry, x equals to 1, wait, 1, and that's gonna be 2. But we do have a problem. We do have a problem here. Let's see if we can make it work, right? So the interval will be changed from lower limit 1, upper limit 2. And then we got this. Okay, we got 1 over u to the power 4. U to the power 4. And then dx, right? So here we got a x dx equals to, we cannot completely get rid of the u, right? We have a root x here, but no fear. Let's try to see if we can work something out, okay? So dx equals to 2 times root x multiply du. So what are we going to do with root x? No fear, but from here, we can solve for root x, okay? So from this relationship, we will get root x equals to u minus 1. Problem solved. Problem solved. All right. Okay. So root x will be replaced by u minus 1. Okay. All right. So when we are replacing dx, we're going to replace dx by 2 times u minus 1 du. So dx will be replaced by that. Okay, so this one has a little bit more complexity. So please practice if you find it a bit difficult, right? So of course, by this time, it's not that difficult anymore. But this is certainly a change of situation. This is has a little more added complexity because you have to go back here, right, to solve for root x, which is u minus 1, and substitute root x by u minus 1, and then the problem is done. Completely x, completely u, okay, and the interval all changed. So let's complete this. Okay, we bring the 2 outside. right? What are we gonna do about these integration? Obviously, power rule is going to be our friend, right? So we're gonna take u to the power 4, divide into each. So what are we getting here? Okay, u to the power 4, divide into u. Oops, sorry. This is going to be, oh my God. U to the power 4, u to the power 4, divide into u, right? So that's going to be u raised to the power of 3 under 1. And the other one is going to be 1 over u to the power of 4. Okay, you can keep the parentheses if you want, but it really doesn't make any difference. Okay, continue. Continue. All right, so we're gonna have, and the rest is very straightforward, okay? So we will have the antiderivative. So you can write this as u raised to the power of -3. And this is u raised to the power of -4. Okay, so, and the outside, we're gonna use 1, 2, right? So the inside, which is the antiderivative. Antiderivative, so this is a 1 minus 3 u raised to the power of -2. Sorry, -2, sorry. Okay, subtracting over here is going to be 1 over 1 minus 4 u raised to the power of -3. Okay, and simplify. Okay, so this is negative half. Okay, -half. And this is -3. Okay, and negative makes positive. So this is gonna be plus third. And the rest is just plug in the numbers. Okay, so I'm gonna do this. I'm going to use curly brackets. Okay, so this bracket, all of it substituting u by 2. Subtracting, okay, this big bracket substituting u by 1. Okay, make sure we have the proper notation. Yes, we're gonna deal with some interesting numbers, okay? And the rest is just to get it done. This is a 1/4, and -half, that's gonna be -1/8. And this is gonna be 1 over 8, right? So 1 over 8 times 3, that's 24. Okay, so that's gonna be 1 over 24. And this piece, this is 1, okay? And this is 1. And you will have to find common denominator. We were gonna have to find common denominator. Here we go. All right. So this is a common denominator here in this part is gonna be 24, right? So times 24, right? 3 times 8. So that's gonna be 24 under 3, right? And so all of it is gonna be -24 under 2. And that part is wrong. Remove that. This piece, right? The common denominator is 6. -3, 6, and this is 2, right? And these two operates, we're gonna get -1/6. So this part is gone. And there's another negative sign outside. So remove this, and that's become plus. Okay? These are arithmetic adding fractions. So this is gonna be 24. So this is gonna be 4, right? And these two operate is gonna be 24 under 2, under +2. All right, so in the end is a 4 over 24. And that equals to 1/6. 1/6. Okay, it's a little bit, it takes some patience to do it. Okay, it takes some patience to do it. All right, last one. Okay, this last one, actually, to tell you the truth, I actually worked on it for a few minutes. Okay, so it is hard. It's maybe hard for you, but it was also hard for me. Okay, so let's get started. So let's see. Obviously, we're going to use u equals to, so this is the most direct intuition. Okay, and 2 would be equal to 3/4 u raised to the power of -1/4. Right, we use the power, oh, sorry, dx. I'm sorry, dx. Right, so derivative of x raised to the power 3/4. So that's 3/4 x raised to the power -1/4. So it looks like we can do the substitution here. All right. Okay. But the question is how we're going to, substitute these two products, right? So what are we going to do? Okay, so no fear. Okay, we're gonna figure out. I hope I'll lead you, so make it not too difficult to understand. All right, so we get x raised to the power -1/4. So we put this in here, it's not gonna make it, right? All right, so we got this. So let's look at the table. Okay, x, u, okay, x from 1 to 16, and u will be from x equals to 1, and this is going to be 2. U equals 2. If x equals 16, right? 16 is 2 to the power of 4, right? So multiply the exponent, we got 2 to the power 3, right? We get 2 to the power 3. 2 to the power 3 is 8. 8 plus 1 is 9. So the interval change is all right. We get that. The interval change will be from 2 to 9. Okay? And this part is u, right? So we got a u here in the denominator. But how about the half times x raised to the power half dx? How would that work, right? Okay. So now what we can do is that we are going to multiply, okay? I'm going to multiply an x raised to the power of, I need x raised to the power half, right? So I'm going to have a -1/2 and x raised to the power of a +1/2. Okay, so this whole piece is 1. Okay, But by doing so, I get x raised to the power half times dx, x raised to the power half times dx. That's what I want. But how about this part? How about this part? This part, we have the same base, so we're going to combine the exponent. So we get 3/4 right there, and x raised to the power of quarter, right? Negative 1/4 minus half. Figure that out. What should that be? That's basically 4/2, right? 4/2, and these two together these two operate, we're gonna get 4/3 negative. And now, and now x raised to the power half dx, we keep it. We keep it. Okay? So what are we getting now? We get a du. Okay, we do a little summary equals to that part. Equals to that. I know. This one is one of the hardest. Okay, this is one of the hardest. And then I want to solve for this because I already have it, right? I already have it. The bottom is substituted. I just need to solve for x raised to the power half dx. So in order to solve for this, what do? I'm going to multiply both sides by 4/3, right? 4/3 times both sides, right? So that will make 1. Okay? Oh, sorry. But I also need to move this one to the other side. So I just multiply x. I would just multiply x raised to the power of a positive 3/4, right? So I would do that to both sides. Okay, that's not a problem, right? That's not a problem. And this way, it's going to be x raised to the power 0. That's 1. 1 can be omitted. So the left-hand side, x raised to the power half times dx, it ended up to be something like this. Then you say, wait a minute, we have x raised to the power of 3/4. Hey, x raised to the power 3/4 can be found in this relationship, right? X raised to the power 3/4 in the relationship of here, that's going to be equals to what? That equals to u minus 1. Voila. Voila. Okay. And now we're ready to move. We're ready to move. So x, right? So this piece will be substituted. I mean, x raised to the power 3/4. Whoops. This piece will be substituted, only this piece will be substituted by u minus 1. So now completely u, okay? And that piece replaces that completely u. Okay? So interval change, integrand change, and completely u. Completely u. So we are almost there. So 4/3. This integration, okay, take it out. And 1/u divide into each, right? So we're gonna get 1 minus 1/u. Okay? You take this out. U divide into u, we get 1. U divide into 1, we get 1/u. Okay, so now we're closer. We're closer. The hard part is over. The hard part is over. Okay. So just find the antiderivative. 4/3. The antiderivative of 1 is u. The antiderivative 1 over u is ln u, right? Evaluate at 2 lower boundary, 9 upper boundary. Okay, and the rest, we're almost done. We are almost done. Equals to 4/3. Okay, maybe we do this parentheses. Too many layers. Too many layers. Okay, so here I'm going to use a bracket. So this parentheses, we're going to substitute a u by 9. So this is 9. This is 9. Subtracting, and we're going to subtract. We're going to substitute by 2 by 2. And then you just simplify. Then we just simplify the next expression. Okay. 9. Here, this has to be a positive. Okay, so 2, 9, so this makes 7. This is going to make 7. ln 9 plus ln 2, right? You don't need to use a calculator. Just leave it here. Just leave it here. If you really want to combine the ln, you can use the quotient rule. You can use the quotient rule, but I will be happy with this answer. Okay, that's the end of it. Number 80, last question. This is one of the hardest. Okay, it takes practice and takes patience. So there's a lot of algebraic manipulation here. So if we are patient enough, we'll get it, and our algebraic skills will be greatly improved. And I think I leave it at that. Thank you so much. Thank you for your time.